Hey guys, we're gonna get started. Don't mind taking a seat.
Yeah, I didn't bring my lines of until. Yeah.
If you don't mind, there's a lot of empty seats in the front. If you can come up front, that'd be great. There's a lot of empty seats up front. Come on forward. All of you guys in the back, if you don't mind taking a seat, we're going to get started.
Hey, Varun,
I'll take one step closer. I go to a very few. Okay, I need these restaurants.
Hi, how you doing?
Okay, so let's get started. So just a few brief announcements. The first, as you know, all of you must have heard next week is Hadoop World up in New York City. I and some of the folk are going to be up there. If any of you are interested in meeting or even just discussing some of the new things that happen at Hadoop World, come hit me up on Twitter, send me an email, and I think that'll be great. Okay, a couple of great announcements I have. The first, the LA Big Data User Group had hit a big milestone yesterday. We hit 1,000 members, so that's a pretty big thing. Also, we did this in 8 months. We started this on February 6th of this year. So in just over 8 months, we hit 1,000 members, so that's really great. Thank you all for contributing and helping making this a success. Second thing, LA Big Data User Group was nominated for a Data Impact Award under the Community Contribution section. So it's going to be next week at Hadoop World, where the awards will be announced. It's hosted by Cloudera. Hopefully you win, so tweet about us and pass along all the love. Thanks once again for making this a success. I'm going to introduce Sarita from Velocify to come and give a brief talk on Velocify and what they do.
Thank you, Subhash, and thank you for the Big Data User Group for giving us this opportunity to host. I'm Sarita. I'm Director in Product here at Velocify. I handle analytics and integrations here. I won't be giving any long speech. It'll be less than 5 minutes, hopefully. So I just want to introduce what we are, what Velocify is, stands for, and what we do, and how we contribute towards the big data world. So this is my agenda is basically to talk who we are and what our products are, the platforms and technologies, different technologies we use here. And we do have a lot of good career opportunities. I just want to highlight what we have. If you're interested, please feel free to talk to our recruiting team at the front desk. So who are we? This is a quick snapshot of what Velocify stands for. We are founded in 2004 and we have about greater than 2,000 active clients today. And our focus is on intelligent sales automation software. So we are a software solutions provider. And our products are basically designed for remote high velocity selling environments. You can see some of the awards we have won in the past, and I'll be going through briefly all that. So here I want to quickly tell you what our intelligent sales automation does. We not only collect leads from all different sources for our different clients, we also distribute our leads and we do guided selling for them. And also we prioritize the leads based on the data, the rich data stores we have for our clients. We have a built-in dial, like a telephony component that is capable of making the calls inbound and outbound and tracking them to make sure the leads are contacted properly and the leads are handled in a way that there is optimal time spent to convert the lead into a successful sale. We also nurture the leads, so ongoing leads or leads that may come return back, we do have a history of them so we can provide more insights, data-driven insights for our customers. And again, there's an analytic component attached to ours, and that's where the entire interest focuses on crunching the rich data set that we hold and then bring it to the next level. So we are working on laying down Hadoop infrastructure as our data lake, and that's what we want to, this whole event is, the intention behind the event is to invite good talent and create interest groups, so we have in-depth discussions on our technologies and the next steps, lay down the path for the next steps in these technologies. So what is our philosophy? We basically, we want to take a scientific approach when we handle our customers and their needs. We also are pretty much data-driven and we provide customer innovations based on the rich data set that we have. All the insights that we provide them is based on data-driven decision making. And of course, our modules are very simple and intuitive. Usability, adoption is the big factor that we have. Customers are everything for us. So I want to quickly show what products we have. Lead Manager product is the core product that we have today. This is a product that's the automation tool where we can handle lead data into our systems. We can run distribution algorithms around it and help our clients see which are the leads that have to be worked on a priority and how to contact them at an optimal time. So cost of business is low and the conversion rates are high. That's what we excel in, and this product is designed for that. And then we have a telephony component called Dial IQ. This is a built-in component that integrates with our main core product, the Lead Manager product. And this is basically helping us as the leads are coming in. We actually go and make outbound calls to the leads, and if the lead is interested in coming back, we facilitate inbound calls, and outbound calls are hooked up to an agent. Very quickly, our distribution logic basically assigns the agent who's appropriate to handle the lead. So this product is a supporting product of our core Lead Manager product. And then recently we released Velocify for Salesforce. This is an application, Salesforce app that resides within the Salesforce app, where Salesforce is enabling the lead management. We actually intellectually optimize the leads coming through, and we act as a strategic partner to Salesforce. How many of you are going to Dreamforce? That's great. So there will be a big group in Dreamforce. I'm glad we have at least one person going to Dreamforce. Please visit our booth, and we are presenting at Dreamforce. I'd love to, have some of you talk about big data and contact with our groups who are supporting the Salesforce, Velocify for Salesforce applications. So these are some of the awards we won. We won the Stevie Winners in 2014. This is a returning award. We've been winning awards for consecutive years now. The Product of the Year award, customer support, we have won awards. So what does our platform basically does? The different technologies we use in our platforms is basically we have a secure platform. We cater to banking, financials, in the mortgage world, in home insurance and auto insurance world. We also cater to debt consolidation and education verticals. So data security is key for, especially on the finance world. So our modules are strictly driven by data security mandates from our customers. We also support about 1,400 plus different partners on integrations. So we have real-time synchronous integrations going through. We support web services through SOAP APIs, REST APIs, and we are making progress in that for the next steps too. Our applications are built on Microsoft technologies. So backend is mostly C# and .NET technologies that we use. Now actually, and our OLTPs, our transactional databases are on SQL Server today. Now we have moved into our next steps, which is in the process right now. We are actually building a Hadoop infrastructure, which will be our aggregated data platform. We intend to use Apache Hadoop with HBase, high MapReduce jobs, etc. And we are trying to pull real-time data, near real-time, I would say in a sub-second, we want to get the data using a Trinity replicate. These are our chosen products at this point. And we are also going into Elasticsearch for scalability and performance improvements. That's our next big step. Soon we'll be progressing into data sciences as soon as we have the aggregated data repository. So machine learning and building a data scientist group is another key thing that we'll be going into. So there are multiple opportunities. You can see engineering opportunities. There are product strategy manager, technical product managers also required. If anybody is interested or would like to refer somebody, we would really appreciate it. And yeah, thank you for listening through. This is a brief introduction to Velocify, and you can see we are 4 times winner of the best place to work for. So I hope you see it in the right angle. Thank you.
Thank you, Sarita, and thank you, Velocify, for hosting tonight's event. So tonight we're going to have David Kewley, who's a senior field engineer at MapR, come and talk about Apache Drill. It's one of the hottest new, I would say, SQL technologies on top of Hadoop. So David, please take it away.
Okay, I normally don't use a mic, at least a handheld one, but I have a feeling this room is big enough that I'm going to need it tonight. So, welcome everyone. Thank you to Subhash and to Sarita for organizing and for inviting me to speak tonight to you on Apache Drill. My name is David Kewley. My title, for what it's worth, is a Senior Field Enablement Engineer at MapR. It basically means I'm on the sales engineering team, kind of working in the background to provide all the things that the sales engineers need to do their job well. Things from demos, training, to infrastructure, to do testing, or working with customers, things of that sort, as well as mentoring and helping them out on a day-to-day basis. So I usually like to start talks by taking little informal polls. I don't call on anyone. Those of you who've been at talks I've given before probably seen me do this. So, how many people today use Hadoop? Okay, not a whole lot. How many people here know something about MapR? Okay, awesome. For those who don't, real quick, MapR is a software company. We are a leader in the field of Hadoop distributions, basically. Our competitors are Cloudera and Hortonworks. So I guess we're using a camera here, so I'm going to stand here. Awesome. Very good. So, so anyway, we're a software company, makers of a distribution for Apache Hadoop. In that way, most of what we provide to folks is all the open source software that those of you have used Hadoop know and love. We also add some foundation layers and storage layer, management layers, and a variety of other things. All 3 major Hadoop companies have their own spin on what they do. Apache Drill is an interesting thing. It's a player in the field generally of how do you do SQL queries on Hadoop, right? It's something that's been a burning topic for the last couple of years, I'd say, easily. There's many different players in it. Drill is one of those players. Drill is a project of the Apache Software Foundation. How many people know something about the Apache Software Foundation? Okay, cool. So that is, Apache Software Foundation basically is a place, an open source community software development organization. Has many, many projects. Started with the Apache web server. Drill is one of those projects. It's currently in incubation. It's actually probably fairly close to exiting incubation and becoming a full-fledged project. Drill is an active public community project. You can go look at mailing lists, you can go join, you can go contribute code, what have you. You'll see a little bit more tonight that might motivate you to do some of that. Drill is nearing release 0.6. I was telling some folks here I'd hope to have a cluster today ready for you to see hot off the presses 0.6 code. At about 4 p.m. I decided to pull the plug in that because I hadn't gotten it working yet. And so we're going back to a working version, but it's really old. It's 0.4. It's from probably 2.5 months ago. In the way of open source projects, especially hot, rapidly advancing ones, Drill is changing very rapidly. You'll see most everything that's really interesting in 0.4 as well, but there's new things coming from the developers all the time. It's already a very usable tool. The very cool thing is it's not only usable on an Apache, or sorry, on a Hadoop cluster, whether it's MapR or an Apache or Cloudera or Hortonworks, but it's also useful on your laptop. Drill is not something that needs a Hadoop cluster underneath it. You can actually download the tarball. It's just Java. Download it, run it on your laptop, point it at a CSV file, and start querying. So we'll see a little bit of that tonight. I won't actually show you running on the laptop, but get some idea for it. Okay. So is this one this way? Yes. Okay. So there we are. Let's do this. This is going to be fun, I can see. Okay. So the Apache Drill project at the Apache Foundation. This is probably, how's the viewing in the back room and that font size? Is it? Okay, good, awesome. So, you know, you can go, and I think that's download, so you can go play with it pretty quickly. There's also a pretty extensive wiki, documentation about all the various, you know, big long SQL reference section, how to contribute to Drill, how to run queries, of course also how to download and install and get it working. So it's a pretty darn good wiki that really can get you off the ground and doing SQL queries very quickly. So, later on today, or in this presentation, I will show you something from these other tabs. This is a GUI of a MapR cluster of, yes, one node, because my fallback was a MapR sandbox on this laptop. So that's what we've got. We've got a cluster of one node. Okay. And then over here is actually the Drill GUI. Looks like it's going off the left side there. Let's see what I can do about that. Doesn't really matter. It fills doesn't really fill the screen. We'll take a look at that later as well, just to give you a heads up of what we're doing. Okay, so a few slides, and then we'll get to actually trying hands-on. Okay, obligatory title slide. Okay, the agenda. So what is the challenge that Drill's addressing? It's basically data agility, and we'll talk a little bit about what does that mean, what motivates Drill, how does Drill address that challenge. Then we'll talk a little bit about what is Drill, how does it actually work. I'll give you a little live demo, and then a few summaries and some next steps that if you wanted to get involved, you know, just kind of pointing you basically back to the Apache website, suggesting you try and download it. So the challenge that Drill's addressing is data agility. What does that mean? Can you guys still see the font in the back? Okay. So when Hadoop started out, its purpose was to address the challenges of very large data. It introduced MapReduce, of course, as a way to do parallel computation on tremendous amounts of data on a large number of computers, right? So when analysts or developers wanted to get access to the data and analyze it, get insights from it, between them and the data, you had to do a fair bit of plumbing development. I think some of you can attest to that, having to write a fair bit of MapReduce, that kind of thing. So that was in the early days of Hadoop. After a little bit, some various organizations contributed various open source projects. An example is Hive, which is the original SQL-like data warehouse on Hadoop, right, that runs its queries using MapReduce, right? So Hive provided a way to run SQL queries on Hadoop. Again, though, between your business, between the analysts and developers and the data, you didn't have to write MapReduce anymore, but you still had to do your ETL, you still had to write your schemas, all those kind of things, right? So there's still some work to do. And how many of you are in, how many of you in your work life pretty much get your IT needs met quickly, either because you are IT or because you run your own machines or because your IT group is pretty responsive? And how many of you experience fairly commonly it takes some time to get things done, would you say? Probably a few more people raised their hands the second question. So this challenge may be familiar because, especially in larger organizations, who's doing this? Often it's IT. And IT needs to do it well, they need to do it right because they're managing infrastructure for a tremendous number of people and projects, they have all sorts of responsibilities, so that can take some time, right? It's kind of inevitable in a mature organization. But you still have this challenge, especially in the modern world of rapidly changing data, rapidly changing competitive landscapes. So this challenge of wanting to get insights on your data quickly, pretty much as soon as it's available. There's probably, there's commonly a lot of thirst by developers or analysts say, hey, we have new data available, we want to start understanding it. Don't necessarily want to wait for this in-between red step. So this is the challenge of data agility. How do we provide the people who are providing insights from the data faster, more agile access to the data? Here's some quotes a colleague of ours took from some customers or prospective customers of ours or organizations. This is basically kind of saying, reinforcing this insight that you need to provide a way for the analysts, for the developers, to have rapid access to the data. It's not to say you're going to be running production with rapid access models, but for generating those initial insights, you need to be able to get those quickly. Okay, well this is where data agility then comes in. This is what Drill proposes to address, is giving the business direct access to the data using familiar tools, specifically ANSI standard SQL, and all the infrastructure, all the tool sets that build on top of that, all the BI tools that some of you may be familiar with. Does that make sense so far? Pretty good sense? By the way, I'd like to have it interactive. It's harder in a big room like this, but if you have a question or a comment or an objection, raise your hand. If I don't see you, speak up anytime. Okay, so what is Drill? So Apache Drill proposes to pioneer data agility for Hadoop. Although, as I said earlier, one of the exciting things about it is it's a tool that doesn't require Hadoop. It can run on your laptop against CSV files. If you've ever had a 1,000,001 row CSV file you wanted to load into Excel and you just couldn't get that last row because Excel only loads 1,000,000 rows, this could be the tool for you. Okay. Developers on it. MapR is a leader on the project, but it's a community project, so there's developers from a number of other organizations. The developer team has a tremendous amount of accumulated expertise in relational databases from all the leaders in the industry. Along with MapR, there's a lot of other contributors of code, including some of these headlining organizations. Okay, so let me see if this goes forward. Yeah. So I'm gonna actually pop up the next thing here. So this probably looks familiar. This is kind of a simple relational table, right? It's got a fixed set of rows, or it's got a fixed set of columns, standards, fixed schema. The column might be strings or integers or dates or what have you. Every row needs to have an entry in every column. Could be null, but that's it. So some databases, before you load the data, you need to define the schema. And so you have to know ahead of time what your data looks like. You have to model it. Maybe you have to transform it to get it in that form, and then you can load it in the database. In other cases, like with Hive, you can define external tables after the files already exist on disk. After this table data already arrives, the data's there, and then you can say, here's the schema. And then later you can change your mind and say, no, actually, here's the other schema. But again, this is probably IT doing this, probably not you. And what happens if let's suppose you're a game developer and you have real-time players around the world playing your game, generating tons and tons of events, streaming in. And you're collecting that data and trying to find some way to analyze it. But your developers, of course, don't stand still. They're not their job to stand still. It's to make the game more and more engaging. And so over time, the schema, if you will, for those events coming in changes. So they add a new character, they add a new weapon, or they add a new capability, or they add a new event. Pretty soon, there's new fields. So if you were to simply take all that stream of events and do some ETL on the fly or batch or whatever, and stuff it into a relational table to analyze what happens when the schema changed. You leave the old schema, well, now you can't analyze the new data. Okay, so I guess we have to change the schema. Okay, so we have to go through that whole middleman process again, maybe fairly often. So this is another kind of challenge. Relational tables don't change. Drill actually can address changing schema on the fly. I don't understand all the details, but that is one of the design criteria for drill. So if you're in that kind of really agile data environment, drill can do something that I'm not aware of any other tool being able to do the same way. Okay, so again, that's kind of your basic relational table, and that sits up in this world where it's a flat row column format and has a fixed schema. Every row has the same schema. There are other table or tabular things that have rows and columns, but it says here schemaless. I'd say maybe non-enforced schema. So in a NoSQL database like HBase, every row can have a different schema if you want. And that has some good uses. And then of course there's also complex data types that either have fixed schema like Parquet or Avro and can be self-describing, or also again self-describing, but can have schema changes on the fly. Every record can be different if you want, like JSON or DSON. Drill can address all of these. So here's an example in JSON. So we have two records here, Michael Smith and Jennifer Gates. And they actually all have it looks at first glance like, oh, they're the same format. No, actually they aren't. Because Michael has a district, but Jennifer doesn't, and Jennifer has preschool, but Michael doesn't. Oh, and look, in hobbies, it's not a simple field, it's an array. And this person has 2 elements, and this person has 1, right? So this is kind of complex changing data. And again, drill can address this. The data source, meaning where does drill look to find the data? That is in the query itself. So first, before the first dot up there, you have a storage engine instance. It could be a distributed file system like HDFS or MapR FS. It could be a NoSQL system like HBase. Actually, I'm going to take this moment. This reminds me. One of the interesting things that's in Drill 0.6, it's a community project. Someone in the community was really interested, because Drill has a plug-in architecture, there's a number of different plug points in Drill. One of them is input format, naturally. And someone said, I really want to be able to query Mongo, so they wrote a Mongo input format. So that's actually coming out with the initial release that's coming out with the 0.6. I'm sure in the future there will be many more written. Right now, the main NoSQL database that comes with Drill is HBase, or the means of accessing HBase. And then, of course, there's the classic Hive. In this case, you're not using Hive to perform queries. Drill performs the queries itself. However, it looks up table schema using the Hive metastore, or hcatalog. Okay? Anyway, you'll see in a second, we define in any given Drill instance what different data sources you have. And in a query, that's what you specify first, is the data source. Within that, you can often have a workspace. So in the case of a file system, it would be a subdirectory, say. In the case of a Hive database, or Hive, it would be a database within Hive, or a schema, as they call it also. And in HBase, it could be an HBase namespace. And then finally, of course, the object within that storage engine and workspace. So that's the actual table. So in this case, we're using a distributed file system referring to a workspace called logs, and that looks an awful lot like path leading to a file, because that's exactly what it is. It's a Parquet file in the file system. You notice something about this. Where's the schema? Well, it's in the Parquet file. We didn't have to predefine it. Okay? The Parquet file exists on disk, drill, no query. That's it. Okay. So again, schema discovery on the fly. So in the case of the Parquet file documents the schema. You can have fixed schema. You can have schema in a central repository like Hive Metastore. You can also do schema discovery. So if Hive encounters a JSON file, it figures out what the structure of the JSON is and allows you to query that structure. If it changes, it adapts on the fly. Just want to give you a little bit of an idea of what a query looks like in drill. So in drill, you have multiple nodes in a cluster typically. Today we're going to have a one-node cluster. But each one has underneath it, for example, a distributed file system like HDFS or MapRFS. Could also have HBase, NoSQL database, could have a number of different storage things underneath it. And generally that storage, in a modern cluster like Hadoop, that storage is distributed across all the nodes in the cluster, and there's some locality information there that drill is able to take advantage of. In order to query a particular set of data, it would like to know, where does that data live? Maybe it lives here. Okay, I'm going to do that part of the query on this node, so I don't have to transfer the data over the network. Drill sits on top of its own distributed cache, and then there's the service, which we call drill bit. So when a query comes in, it can go to any drill bit. Doesn't matter. Drill bit, I think it's called the foreman in this case, the foreman for the query. It generates the execution plan, and then it farms out fragments of that execution plan to individual nodes, which then do their work, and data comes back to the returning node. And I don't know if there's one more click here, but then that obviously goes back to the client. Oh, no more click. Make sense? Kind of basic idea? Yeah? Okay. So here comes the fun part. Watching me try to talk while typing. With a held microphone. Okay. Let's see.
Want me to hold it for you, David?
That'd be great.
Okay.
Thank you.
Don't get used to
This is my colleague Heather.
Don't get used to this language.
Yeah, I know. Thank you so much. You want to start? Yeah. Okay, cool. Thank you. Okay, so let's see. We are here. Actually, I'm going to see if I can turn this podium so I can see it a little bit better. Yep, easy. Awesome. Thank you. Okay, this is not what you're going to, probably a little closer. This is not, thank you. This is not what you're going to have to look at. Let me pull up one that actually has a font you can read. Okay. And again, I'm going to have to bring that down and stretch it. This is just, for those of you who use Windows like I do, this is just PuTTY, but inside a thing that gives you different tabs, which is basically PuTTY. Okay. Now, where's my mouse there? The mouse, and where's my script? Let me take a moment, ask you guys, is anything coming, thank you, I'll go ahead. Is anything coming up, any questions or comments coming up at this point you want to raise? Yeah, go ahead.
For the schema list, will drill, do you need to convert like a tab delimiter to a comment delimiter to Parquet for it to understand it?
So you said, do you need to convert from it? You said, do you say tab to comment or Parquet?
Yeah, comment delimited or tab delimited files, do you need to convert those to Parquet files?
No, that just was one example, but we'll see actually, it'll read, for example, CSV or TSV directly. Yeah. We're good? Okay, so let's go to, where is it? Here, okay. So now I have to find the mouse. This is always fun. Okay, so again, this is a MapR cluster of one node. Let me stretch this guy a little bit bigger. This is the MapR control system, our web GUI. One healthy node, a whole bunch of navigation items over here for different aspects of monitoring and managing the cluster. A brief description of the utilization of the cluster as far as CPU, memory, and disk. Can you guys in the back see okay? Yeah, okay. Brief description of resource utilization for MapReduce, okay. And then a description of the services that are running on the MapR cluster. The one we're going to be focusing on today is DrillBit, which we just talked about. There's a bunch of other things running on here. You see Job Tracker, Task Tracker, so this is also a MapReduce node. It's also running Hive Metastore because that's also how Drill gets information about Hive tables is by querying Hive Metastore. What else? Do we have Hive Server? Yes, Hive Server 2. We have Hue, Uzi. Those are probably the highlights. There's a few other MapR specific things that if you guys are curious, we can talk about. And then MapR has volumes in its storage. This cluster just has 12 volumes. So there you go. Let's see. Actually, okay, thank you so much. Okay. Let's see. Okay, so I wanted to show you a little bit about this guy. So this is the Drill GUI, and it's advanced. This is again Drill 0.4. There's actually some things added in 0.6, but there's things about the queries that have been. You can run a query from here. You can look at query profiles from here, as far as their logical and physical plans. You can look at metrics about various, I guess, JVM and probably drill service details, and then classic JStack output to look at your Java threads. But the main thing that we use most of the time is storage, which is where you manage these storage plugins. That was the first part of the table specification as I described before. So in this case, I have 3 enabled storage plugins and a few disabled just because, just keep them out of the way, not using them for this demo. We can query Hive. We can also query MapRFS, the MapR distributed file system underlying this cluster of one node, which is just like any file system query. It uses multiple paths. It's essentially HDFS, but using the MapR RPCs, if you want. And then there's this thing in between, which is MapRDB, MapR database. The MapR database is something that is HBase equivalent, but it is part of the MapR file system. There's a number of advantages to that as far as speed, reliable, low latency, et cetera, but the API that you use to access it is HBase. So I'm just using that as a stand-in for HBase in this demo. So if we take a look at these, we click on Update to look at them. So Hive, how is that defined? It's simple. What type of storage plugin is this? It's a Hive type. It's enabled, and I tell it where to find the metastore. And then there's some other thing here which I don't even understand why it's necessary, but something about saying, no, we're not using Sassel. Similarly, the MapR database says, oh, I'm type HBase. This is a MapR specific thing, which basically says because HBase has a flat table namespace, there's no paths in that namespace. But MapR tables live in the file system. We can do a mapping from all tables in the flat namespace, asterisk, to a directory in the MapR file system. So it's just a way to map HBase's flat namespace into a given directory in MapR. And yes, it's enabled. And then finally, the most complicated one, the one that gets to the question earlier, I think, about multiple formats. It's MapRFS. So it's a storage plugin of type file. It's enabled. This is the URI. So again, we can also use just regular file. We can use HDFS. Same idea. The default location is all my data sits under here. And then it has some other workspaces defined. So root is actually the same thing. It has a workspace called nested, which sits under there, under directory called nested. These are all convenience things. There's a lot more interesting uses you could put them to in production. Flat is flat, views is views. You notice at least one of these is not writable. The others are writable, which means that I can do a create view and save the view definition in one of these workspaces, or I can do a create table as select and save the resulting table, for example, as Parquet files or CSV files in one of these directories. And then this defines formats. They look pretty simple to me. I mean, there's several text formats. They're text delimited. What's the file extension? What's the delimiter? Oh, type character. Okay. CSV is a comma. TSV is a tab. And then there's a couple of definitions. I'm honestly not sure why this boilerplate is even necessary, but it is. So you can also handle Parquet and JSON. So these are what's defined today. Again, MongoDB is introduced in 0.6, and it looks like others will be coming down the pipe. Any questions? Yeah.
What's a quick description of the plugin architecture? How would you be able to write a plugin for, let's say, MongoDB or let's say something else?
You know, I'm actually, sorry?
Just something quick. You don't have
Yeah. So he asked, what's a quick description of the plugin architecture? What would it take to write a plugin for MongoDB or something? I write code, but I'm really not a Java developer, but that's what you'd have to be basically to write a plugin. And so I don't know in the world of Java developers when they're writing plugins what standard ways of talking about that are. I do know that there are several different plug points. So there's the input. It's not just an input format. If it's something like, I'm sure someday there'll probably be MySQL. It's not just a way to read data, it's a way to query metadata about the data, including localization, row counts, I don't even know, but things that are necessary to do optimization syndrome, right? So if your storage format has those kind of capabilities, then you can expose those in your plugin. But there's storage format, I think there's going to be at the optimizer layer. Honestly, I don't know. That's on a different slide I don't have up here. Is that helpful? Okay. Anything else at this point? Okay, let's see. I think that's about what I wanted to show you there. So I'm going to show you something else now, and again, this is also evolving. So the core drill project is Java, and it's developed in the Apache Software Foundation drill project in incubation. There's also an ODBC driver. It's developed separately. It's not developed inside the context of Apache, but it's something that we provide on our website for drill, and it's a professionally written ODBC driver. So let's take a look at that real quick. So Windows 64-bit ODBC administrator, look at system DSM, look at the one that's pointing to my sandbox here. Configure. Oh, thank you. I'm looking at it. Okay. So the basic idea of configuring this thing is how do you connect to a given drill cluster? So one way, drill keeps various configuration parameters and also keeps track of who's a member of the cluster by self-registering the zookeeper. You have to tell it where the zookeeper quorum is, and it takes care of the rest. So likewise, the ODBC driver can also query the zookeeper quorum to ask where are the drill bits, where are the servers, and then you can then use that information to farm out queries successfully to different drill bits. Or you can connect directly to a given drill bit. That's what I've chosen to do here. And if I test, it says, oh, where's it gone? Test? There it is. Test failed. Okay. Why is that? Well, this is. Some of my colleagues swear they'll never do a live demo. Let's take a look. I'm going to do a little bit of probably non-talking troubleshooting right now to see what's going on. Okay. So it's listening. So why didn't that work? I'll show you guys the error real quick, just so you see it. Error occurred while trying to connect invalid advanced property type handshake timeout. I had this working earlier, it's ready. Well, anyway, I tell you what I'm going to do. Oh, thank you so much.
I was going to do it.
Thank you very much. So I don't, rather than spend time trying to troubleshoot that, what I'm going to do is show you the CLI. Go ahead.
If you look at the bottom, there was a place where you could remove that handshake timeout. I would say before we go ahead,
Sure.
try that out. I think that might work.
Try what?
So if you look at the dialog box
Yeah.
on the bottom, so it said handshake timeout.
Yes.
Wrong.
It did.
So advanced properties, if you just remove that property, maybe
I'm not sure. No, I totally agree. I just don't know where that property lives.
right at the bottom, advanced properties.
Down.
There's the handshake timeout equals 5.
Oh, there it is. Thank you.
Yeah. So
I didn't
maybe you
notice
can
that.
remove that.
Yeah, let me try it. Okay. Interesting. Good eyes. I hadn't ever noticed that. Let's try it again. Okay. Advanced property query timeout. It's not complaining about. So let's aggressively. Let's just delete all of them and see if that fixes it.
Maybe it's the 0.6 advanced properties.
Yeah, you know, I when I downgraded. Anyway, I thought I had things working before I left home. Okay, well, whatever. Let me see. We need that last one, I'm pretty sure. Try deleting that. And delete that and try that. Successfully connected. Thank you. Okay, look at that. Troubleshooting the public. Awesome. Okay. Thank you. So the drill ODBC driver comes with this thing called Drill Explorer. So let's pop that up real quick and pull it over because it likes to put it on the primary monitor. Okay. So this is a way to GUI browse through the ODBC connection and drill. So we saw before that we had Hive defined as storage plugin, MapR database defined, and then some MapR with some different workspaces within it. So they all show up here. So if we look at Hive, well, what tables do we have? We have 2 tables, customers and orders. Okay. MapRDB, how about you? Oh, you have a table called products, and you have column families, details, and pricing. MapRFS, how about you? Well, what do you have in your flat? You have a logs thing. So let's actually not click on logs. Let me click on. Actually, sure. Let's click on logs. See what happens. It may take a moment for it to query. This is a poor little laptop. And if this hangs, I reference my colleagues who say I never do it as often. Okay. Yep. That was fine.
What should it be doing, David?
It should be. Just took a while. Awesome. Again, help from the audience letting me know that it came up. Okay, great. Okay, so cool. So these are all the columns defined in flat files. Honestly, we should go take a look at this directory and see what the flat files are. So if I open this up, there's dates, so there's years, and then under that there's months, and then under that, like January, there's a file log.json. So these are JSON files, so self-describing, and they say, hey, look, I have a field called transaction ID and other fields with all these names. Drill has added 2 fields, dir0 and dir1, which are based on the directory names. And so this is sort of an automatic way of doing partitioning. Just drop it in the directories according to how it should be partitioned. Don't bother defining partitions. You can simply use quote-unquote partition names like dir0 or dir1 in your queries. Okay? Okay. Let's see. Hive database, for example, customers. Okay, there we go. Even tells you the schema there because it's been defined in the Hive metastore. Etc. See what happens when I click on this. You get some funny things because these are still printing as Java object information. Later we can do casts and stuff, and these will get turned into human readable things. Okay. Yeah, gotcha. Okay, let me see what I wanted to show you guys. Okay. Yeah, let me take a look. Now I think I could actually use microphone now. Finally, I'm going to type. Yeah, thank you. So let's see. Let me come over here and paste. Okay, so this is the same thing we saw before, but now it's in the file system view, right? So we are in MapR, demo.mapr.com, which is the name of this cluster, directory, tree, data, flat logs. There's your dates, there's your months, and there's your file. That's what we just saw in Drill Explorer, okay? And there's a JSON file. This one happens to be flat, but you can also query nested JSON files using dot notation to dive into the structures and array subscripting to dive into arrays. There's a flatten operator on arrays coming up, I promise. Again, I'll mention that the SQL in Drill is not SQL-like, it's ANSI SQL. That said, it has quite wide coverage, but it's not 100% yet. It's also not GA yet, it's still in beta. Let's see. So I think we did all that we need to do. So let's run the drill. Let's run the drill. There is a drill GUI called, a CLI called SQLine. It's actually an existing project. Okay, so that didn't work. Let's do opt. Actually, CD out of there. Opt MapR drill thin SQLine. SU JDBC drill. Okay, show databases. One second. This is a good time maybe to go to the wiki. This is something I know in my sleep. I swear I do. I don't know why.
The demo syndrome.
It's a demo syndrome, exactly. Okay. Yep, it does. Challenge is taking whatever comes. Okay. JDBC drill. Yeah, but that is necessary. Yeah, that's what I did, except for ZK local wasn't necessary. So why am I yeah, I don't know why that is. Maybe I have to do this. Let's try this. This first of all. Let's try. Is it this? Yep.
That's not.
I'm a little rusty. Why is this not working? Okay, well, you know what?
Maybe the driver was in the root user, not the current user. Sometimes.
Maybe. Actually, that's a good point. Let me try steering to the root. I think it should be. I think it should be defined for everyone, but. Why am I? It's a ABC drill. And, okay. Hold on a second. Let's see. It shouldn't need to be in a particular directory. You know, it's kind of, I expect to have run into problems when we get further along. I don't expect to not be able to run the folks who have played with drill, if anyone's played with drill, do you have any ideas what I'm doing wrong?
You want to try feeding Zookeeper local?
I could try it. I don't know. I don't think I'll get my definitions. I could try it. So what this does is normally drill relies on Zookeeper. What did I just do? Equals, yeah. Something weird is going on here. I don't know what it is. Yeah. The one comfort that comes at times like this is knowing that probably the majority of the people in the room have
Run
Yeah,
it
you
as
never-
root, so you have permissions on the file.
permissions of which file?
Can you run that command as root?
We just did.
Yeah, and it gave me basically the same error.
Nobody's never seen one.
Sorry?
Paste connection.
Say again?
Paste connection.
Oh, test the connection?
Yep.
Let's see. So if I do service MapR zookeeper view status. What is going on here? Oh, sorry.
Too many
Too
O's.
many O's in the Z.
I had two O's, thank you. Zoo.
I was like,
Okay.
that's scary.
So it's a standalone mode as it should be. And then let's do also F-I 31010, which is where drill listens and it's listening. So let's do Sue and kick it. Actually, I don't need to Sue. I can do MapR CLI node services name drill. It's one way to do it. There's a bunch of other ways too. This is the way I like does it clean cluster wide if you want. Action restart filter configured service. Run on those nodes. Filter that's configured. That should restart it. What's going on today? Node services.
Services.
Okay.
You're the only person who's ever gotten errors.
Yeah, I know. Do I have a CLD that's active? Yes, I do. Okay, here's what we're going to do. Service, MapR, warden, restart. Actually, I need to do it as root. Service, MapR, warden, restart. So while it's doing that, I'll just talk a little bit about MapR architecture. So warden is a process that, with the exception of Zookeeper, it oversees all the other processes that are launched, that are configured to be launched on MapR nodes. So by doing this, I'm basically restarting MapR services except for Zookeeper.
Did you actually remove the advanced parameters that we were able to?
I did, and those advanced parameters were defined in the Windows ODBC driver, and now I'm on a Linux CLI, so the Windows ODBC driver should be in here. So, and I recognize that we're getting close to the top of the hour, and we want to shift at about the top of the hour, right? Okay. Okay. So let's see if CLDB is up. CLDB is, I can exit. Master, and don't quite have a CLDB master yet. So the CLDB is a MapR service. It's the container location database. It's part of the cluster management. It's basically a cluster management daemon, and it keeps track of, at a very high level in the abstraction tree, if you will, keeps track of large chunks of data in MapR, data on the order of 32 gigabytes in size, so it doesn't have a whole lot of those objects to keep track of. Let's try again. This worked at home. There we go. Fine. Okay. So let's do LSOF. There we go. Let's try opt fill SQL line. And are we going to be happy this time? No. Not, oh, I got a null pointer exception this time. Awesome. I have never seen this before. Okay. Today is not my day for demos, so maybe especially since you guys got to see me play around with this one. At least I hope you got an idea of the abstraction of it. I've given 2 other talks, actually. Heather and Jim have both seen me giving 2 other talks down the coast. It worked. So I don't know what's going wrong tonight. Naturally, the largest audience, but whatever. So let's go back to the slides. Thank you. Okay, so live demo of figuring out how to make it work. It did. So again, how do you guys get to try this if you're interested? And I know that the demo wasn't entirely convincing. You'll have to take it on faith that this normally works. Sorry, it didn't work tonight. So if you're interested in giving it a try, running SQL queries on files without having to manage any metadata or anything on your laptop, download some data like from City of Los Angeles. I just tried that today, started playing with it. You get CSVs of crime statistics or wherever your favorite data source is, maybe even something at work. I find work problems every so often, like when I'm managing Amazon instances, EC2 instances, you can get information back from Amazon naturally in JSON format. Love to query that using drill. So CSV is a nice, easy way to start. Maybe you're used to viewing it in Excel, but instead of that, just download the tarball for drill, untor it, run SQL line. It should work, really. And then query away. Pointing your query at, once you define a simple storage engine, pointing your query at path to the file, and start doing SQL queries on a CSV right on your laptop. Thank you. And you saw the download link before, and that is basically it, except I just wanted to give you a little bit of an idea about MapR. One slide. Again, the core of it is all the open source stuff you're used to using or at least hearing about. Underneath that, underpinning it, providing a good foundation for it is the MapR data platform, which is the MapR file system and the MapR DB that I tried to show you in action today behind the scenes underneath the drill. Alongside that is the management GUI. Everyone has their own. Ours is called MapR Control System. And we provide all those white paper benefits, truly. So one thing actually I want to point out in this is that drill is here. Shark, this is actually an old version of the slide. Shark is going away. Some of you may know it's SQL and Spark. There's now actual Spark SQL, plus folks are including MapR, are working on running Hive on Spark. So there's a number of different SQL efforts out there. The cool thing about MapR, you don't have to choose. So if you want to run drill, you want to run SQL, Spark SQL, eventually Hive on Spark, you want to run Impala, you want to run Hive on Tez, you can do all that on MapR. So we kind of take an agnostic approach. We don't want to tell you what you need to run. You can try all of these, see which one fits your needs best. And that is it. Thank you very much for your attention. Do you have any last minute questions? Otherwise, yeah.
Are there any hardware considerations to come across running drill, like power protection, or any just general server considerations?
So the question is there any hardware considerations when running drill? One of the main ones probably is that like any database is going to do better when you have more memory. Like any parallel infrastructure is going to do better when you have better network. It runs on my laptop, not powerfully. I've heard from folks who are trying out the drill beta that when you run it on good hardware, on a good network, you can get really some awesome performance, even though it's already beta. It's only beta and it still has a lot of optimization to go. Okay. Anything else? Yeah.
Do you know what data set sizes drill is designed for, or maybe the largest data set you've seen it deployed against currently?
I'm not sure. So the question is, what data set sizes was drill designed for? What's the largest data set I've seen it deployed on? Unfortunately, there's so many things happening with drill, I don't have awareness of everything. I've mostly played with small things myself, and most of my colleagues have. I think I just heard on our internal chat room the other day, someone was playing with, I want to say, multi-terabyte data sets in a single query. Drill is really focused at that agile data exploration, insight generation thing. It's not designed primarily for like data warehouse, batch processing, ETL, that kind of thing. You can do ETL, but it's really meant for interactive use. And so in that sense, it's really going to probably do best. By the way, one thing, it will run best if all the data fits in memory, of course, but it will spill to disk. And so if your data set size is larger than memory, that's fine. We'll use disk. It'll just go slower because disk is slower unless you got SSDs. So. Okay. Another question, I see?
It sounds like it pulls things into memory to do its querying. Does it do any caching beyond that? Because remember, if it did something before, it's going to already have a result, or just relying on the system that it's using to do caching.
So the question is, so pulls things into memory, does it do any kind of smart recognizing that it ran a query before and keeping something about that query graph's results or data sets itself? Fair rephrasing? Does it do any kind of caching or smart things? To my knowledge, not today itself. I wouldn't be surprised if that's some of the optimization will be added eventually, but not today. Today, MapR or any file system would probably be largely sped up by the caching done by the file system. So, I probably should let Subhash go on. If you guys want to chat after, happy to talk to you. I'll be sitting up here and we can talk. Thank you very much again.
Thank you, David, for presenting. I'm just going to give a brief presentation. It's going to be very short. It's just a focus on, where Hadoop is currently and where Hadoop is going.
Thank you so much, David. Big round of applause, please, for introducing us to. So I'm sure all of you pretty much very well know Subhash, but here are folks from the last 5. I'd like to briefly introduce Subhash to you all. Subhash is an evangelist, has been selected as the Big Data Champion by Cloudera. Subhash is also organizing or founder of many of these LA user groups, LA Big Data User Group, and Apache Spark, HPC User Group, etc. And if you want to follow his on Twitter too. So please listen to Subhash about a few introductory notes on Hadoop. And thank you.
Hey guys, so I'll make this short. I won't try to keep you too long out here. So what I'm just going to talk about is basically where Hadoop is today and where it's going. I think one of the big things I've seen, at least in my experience for the past several years, is Hadoop has evolved drastically from its, its beginning days at Yahoo to its evolving in the community to right now, its use cases just tremendous and wide. So where Hadoop is going, what are the new features? I'm sure a lot of you have heard of some of the new technologies out there, and some of you are wondering, what are all these new technologies? How can I use it? Where does it make sense to use? At the end of this, I'm not going to suggest you to use one technology over the other. I believe everything is driven by use cases, and every use case has its own technology to use, its own tool to use. So to see where Hadoop is going, I would say, look at where Google is today. A lot of where Hadoop came from was from where Google originally defined itself. Some of the papers that defined Google's early initiatives in this GFS, MapR, and Bigtable. And to see where they're going, just see where they are today. And I'll have a slide that actually shows you where they have actually evolved to, and look at the different features that have come in from there. In fact, there's a great talk by MapR CTO, MC Srinivas. Next week he's giving a keynote, and he's going to be talking on this specific issue on Hadoop and Google, and it will be one of the keynote presentations if you're at Hadoop World next week. So to see where Google is today and where we are, just look at the information. So this slide is taken from John Say from Cloudera. He did a very good presentation at Big Data Camp LA. So I just want to show you, go with this slide once again. So GFS has morphed in Colossus. That's Google's next version of Google file system. And currently we are in HDFS. So HDFS yarn is currently where we are. And if you want to see where we probably will, something close to Colossus at some point. Maybe even there with yarn. Bigtable, was what HPC is currently for us. They moved to Megastore and now they're at Spanner. And Yahoo was at Peanuts, now they're at HBase. We are still at HBase. MapR, still at Google, but Yahoo and Facebook have moved on. Still same Hadoop MapR. Google MapR also actually is gone out from the last, Google I/O. They did mention that their MapR is kind of dead for them as well as for the rest of the world. And they have, I forget what's their next version of it, but they do have something which tackles MapReduce, it becomes more interactive to MapReduce. For us, it's Hadoop MapReduce and Spark. I believe Spark will be the next generational level gap between the two. Batch query, you have Sawzall, Tenzing, Flume Java. For rest of us, Pig, Hive, Impala, Drill, Crunch, a lot of that is there. Bog, which became Omega. Yahoo's got Yarn, Facebook, Corona. Rest of us, Yarn and Mesos. Evenflow, custom MySQL proxy. These are the ingest engine. Yahoo is using custom. Facebook has Scribe, and rest of us, Scoop, Flume, Kafka. Similarly, for coordination, graph processing, and stream processing. I won't go into too much details out here. If you want these slides, I'll give them to you. But this basically shows where Google is currently now, where we are currently now, and where we're moving towards. So as I said, if you want to see where we're going to go towards, just see where Google is currently today. So where do I believe Hadoop is moving towards? And two things I've seen in the past several months, and a lot of it is driven by the customers. A lot of the vendors who spend time and focus on Hadoop technology, driving tools, is basically defined by what the customers want. The two major things that our customers have asked is security and real-time analytics. And I've seen a lot of work being going on currently in these two areas. We'll just go a brief description over some of these and maybe go over some of the technology and tools in each one of these areas. So security, Hadoop vendors have become more security friendly, serious about it. In the past year, Hortonworks has acquired XA Secure, Cloudera acquired Design. For a long time, Kerberos was the authentication. Now also, the authentication mechanism, Kerberos seems a pretty powerful way of authenticating in. But things like audit control and MDM has become important as well. So with these acquisitions, Hadoop vendors are positioning for themselves for better security play. Cloudera has Apache Sentry, Hortonworks Apache Knox, and MapR supports security with authentication and authorization. Real-time analytics. So a lot of, I think the way to define real-time analytics is to split up into different parts. That's the way I see it. There's real-time streaming, that's getting the data into HDFS or MapRFS or some of these big data stores. And the second thing is actually processing the data in real time. That's why I think it's actually two different things. And then looking at it from that perspective makes more sense. So real-time streaming is quickly ingest data as it comes in. So as you generate data, let's say someone visits a website, clicks through on things, goes through, starts clicking through, does one thing. For every interaction with that website, that generates a particular log line, either Apache or forget the other one. Nginx, sorry, Nginx. So it generates one of those log lines which you can actually use to process the data. So anything. Also, if you think about Internet of Things, if you look at parking meters, you put a credit card in, there's a transaction that's generated. That could be thought about it as an actual event happening. So anything that happens in real time, you want to ingest the data. As fast as you can, you want to ingest it. As fast as you can, you want to process it. So real-time streaming will be real-time ingestion of the data. Real-time reporting will be actually processing the data. So let's talk about the tools that fall under these two different levels of abstractions of areas. So real-time streaming, I think I just put up 3 tools which I think are really popular in the community right now. There may be others out there, but these are the ones I think there's a lot of focus on. So Storm, Spark Streaming, and Samza, we'll go over them one by one. So Storm was one of the first ones out there to do real-time streaming. Very low latency, typically 10 to 200 milliseconds. It's started by Nathan Moss from Backtap, acquired by Twitter. Strong support from Hortonworks. One of the big disadvantages, or I would say big, but kind of like a disadvantage is the APIs are much lower level than Spark. So you need to know Java at the core to actually play around Storm. The other thing is that Storm has Trident. Usually when people say Spark and Storm are similar, it's not actually true. Spark streaming is the one that people usually compare with Storm, and it's not even the Spark streaming that's exactly similar to Storm. It's Trident, which is actually the micro batching part of Spark streaming. So when they talk about Spark streaming, it's actually macro batch events, and that's what Trident is, which kind of mimics Spark streaming. So Spark streaming is based on the fact that not all data is required instantaneously. This is what I was talking about micro batching. So everything is instead of getting just one event, you probably get like 3 to 5 events, a small size of event which you actually then process. The latency is 1 second. So typically, if you're looking for very low latency and really quick streaming, I would suggest go with Storm. Otherwise, Spark streaming can help in that arena. Problem with Spark streaming, it's got single point of failure. It has scale issues. Great for machine learning, but support is great from in the industry. Databricks, Cloudera, Hortonworks, MapR, DataStax, Pivotal. Also, one of the great things about Spark streaming is if you use Spark streaming, you can directly integrate with Spark. So if you use some other tools like Spark SQL, not Spark SQL, but MLab or GraphX, it kind of makes it easier to integrate with that. If you have any questions, just raise your hands. Make it much more interactive. The last streaming process I want to talk about is Apache Samza. It's an incubator project. This is stream processing engine from LinkedIn. It's built upon Kafka and Yarn, very similar to Storm. I think one of the big, I would say, differences between Samza and Storm is Samza offers one level of guarantee versus Storm, which offers multiple levels of guarantee. So now I just want to talk about real-time reporting. I would say near real-time because there's nothing like real-time as such. But a lot of the vendors are working towards making their products or tools more real-time. But so some of the tools we're going to talk about, High-1Days, which is a Stinger initiative from Hortonworks, Impala, Drill, as which David just went over. So I'll just give a brief overview. Spark and Hawk. Again, these are just brief overviews. They're not to give you distinguish one between the other, but mainly just to go what the tools are and what features that they offer. So High-1Days, it's Apache project, both of them Apache projects currently. Days is the new application framework for on top of Yarn. Any workflow that's derived is actually compiled to DAG, directed cyclic graphs. It optimizes MapReduce jobs up to 5 times faster than standard MapReduce jobs. It supports in-memory jobs for small data sets, supported by Hortonworks and MapR. So it's one of the things with Days, and this is what I've heard, is Yahoo extensively tested out, and it's tested at scale, and they found it to be really scalable. So DataMere, another VI vendor, they have actually implemented Days in their frameworks, just based on this thing that Days is much more scalable than Spark is currently. Even though they want to do Spark, but Spark has proven not to be scalable. There's a lot of work going on Spark, and I'll talk about a little bit of Spark in the next upcoming slides. The next one is Cloudera Impala. Impala was one of the first, I would say, interactive query engines out there. They probably went GA a couple of years ago. So it's a massively parallel processing architecture for performance with Hadoop scalability. Performs interactive analysis on many data stored in HDFS and HBase. It's got Hadoop security built in, so it's able to be integrated with Kerberos for authentication and Sentry for fine-grained role-based authorization. It supports ANSI 92 SQL and supports a lot of the file formats, text, sequence files, Avro, LCORC, and Parquet, supported by currently Cloudera and MapR. Drill incubator project, as David went over. So I'm just going to go quickly over it. So clustered, powerful MPP query engine for Hadoop and process petabytes of data. Useful for short interactive queries on large-scale data sets. Capable of querying nested data in formats like JSON and Parquet. It does not require a centralized metadata repository and provides query on sub-describing semi-structured data files such as JSON, Parquet, and HPC tables, and supported by MapR currently. The next one, and this is the one I think there's a lot of work, initiative and momentum behind. In fact, I feel currently where Spark is today is what Hadoop was probably 4 to 5 years ago. A lot of people are thinking, testing, looking at it, wondering where it's going to go. Spark is currently in that particular position. There's a lot of initiative, a lot of work, a lot of positioning behind making Spark much more robust and scalable. So getting onto Spark right now is kind of makes a lot of sense because I believe in the next few months to a year, Spark is going to become scalable and more robust, and there's going to be a lot more acceptance from the community and vendors in general. So consider multiple projects: Spark Streaming, Spark SQL, MLib, and Graphics. It runs on top of Yarn, Mesos, even EC2. Uses concept of RDDs, resilient distributed datasets, which basically says that data is immutable during transforms. It enables in-memory processing. I think a lot of time when people say, Spark is really fast, it's because they keep thinking of the in-memory part of it. But you got to remember, in-memory only is in-memory for as long as the data can go in memory. If you have a large data set, this pretty much does not apply. So it typically applies to cases where the data is small enough to fit into memory. Again, supported by multiple vendors, Databricks, Cloudera, MapR, Hortonworks, DataStax, Pivotal. Also, strong support from Hadoop community. Mahout, which is run on Hadoop or MapR uses, but they are currently moving to Spark. So is Cloudera or X, which is one of the data science tools it's currently implemented by Cloudera. Another, NoSQL tool or real-time SQL and Hadoop tool, I would say, is Pivotal Hawk. It's part of the Pivotal platform. Full SQL syntax support, interoperability with HPC through Pivotal extension framework. Interoperability of Pivotal's Jump5 XD in memory real-time database backed by HDFS. Everything is proprietary to Pivotal platform. So what to use where? I think it's highly dependent on use cases. Everything has its own place in the ecosystem. I believe you use the right tool for the job. Sometimes there's several tools for the job, and if you notice that, especially in the Hadoop ecosystem, there's so many different options out there. Sometimes you don't even know what to use. So in those cases, I say, use what's the most easiest and scalable to the enterprise in such scenarios. So that's all I have for just to go. I just did a brief overview of the SQL on Hadoop options, real-time streaming, real-time analytics, and security. Just to give you where I believe Hadoop is going towards, and you'll see a lot more effort and work in this particular arena. Any questions on this? Any input, feedback? What do you guys think? This is my opinion. I feel really strongly about it. No opinions, so I guess you agree with me?
Everybody agrees.
So is this a question out there? Yeah, go ahead.
I speak pretty loud. So when you talk about the visualization tool, what are we visualizing when it's such big data?
So these are actually visualization tools, or more of tools of doing interactive query with the data sets, I would say. It could be visualization, but I think there is better visualization tools out there. You have things like Tableau, Pentaho, Datamere that will actually allow you to visualize, and those are the tools, BI tools that actually work with these, I would say, SQL and Hadoop interfaces to actually visualize the data. These are tools that make things run faster. I would say run faster or run in near real time. Again, near real time is very subjective. It depends on the data set, depends on what you're trying to do to get near real time. But these tools are mainly focused on making your queries much more faster, so you can actually see the results. So for example, if you use a visualization tool like Pentaho out there, you probably want to see your responses, your charts, your data. You want to see the responses that really fast. These things make it happen much more faster. Any other questions?
There's a mic I can hand over. Anybody want to ask the question?
So just to give you one more update is that these are just a small subset of the tools out there. If you actually look, there's still so much work going on there. In fact, for Spark, there's actually an incubator project called FigD that started by someone in Germany. The great thing about open source is that everyone goes and creates their own tool. So it's great that it's out there. Problems, there are too many options. You don't know what to pick and choose. So I hope this is to give you a brief understanding, and hopefully you make the right choices for the tools in your company based on what you actually need to do and based on what's easy and scalable for your organization. Thanks for
do you have some interesting I was just going to say, do you have some interesting use cases where people have been on iOS and Android? They've been looking to kind of move towards a faster architecture, let's say going from Hadoop to Spark or something, just to kind of speed up their response times on applications for
I don't know a use case off the top of my head for iOS or Android, because most cases, unless you have a really big data set, you really don't put it on Hadoop for processing. That being said, I'm sure there's probably some applications out there that do use it. I just don't know anyone on top of my head that currently uses iOS and Android for. I use out of iOS or Android, data sets, and I think that'll be interesting to see if there is one out there and how to use it.
I think Motorola is using currently on their Android system, they're using Google Big Data solution. And one of their use cases that I hear from them is they're tracking every user who's on an Android system, how the usage patterns are looking like, the rate of discrepancies in their system, like how many users are now unable to reach the applications on time, latencies and crash details. They're tracking them on a near real-time basis, and they have a built-in module to raise a Jira ticket in their systems internally and an escalation process behind it. Currently, there's a small use case that they're using. Soon, they're going to make it more robust, is what I hear.
Is that BigQuery or Hadoop?
It's BigQuery.
BigQuery. So BigQuery is another SQL on, I wouldn't say SQL on Hadoop, it's definitely not Hadoop, but it's SQL on Google's database. Well, I've used BigQuery, it's powerful, works really, really well. It's got some caveats and some problems, but it's still really, one of those big query tools. You have to use, it's kind of like Amazon's, which is the Red TV, which is the one from Amazon? Redshift. So kind of like you need to have your data in AWS, or in Google's case, you need to have it in Google Cloud DB before you can actually use it. So it's one of those things, but it's really powerful. I've actually used it. It's, it really comes back and really. I've used it on, I would say terabytes of data, and response times is fast. There again some caveats. It's got some funky details in the SQL interface, but it's powerful and fast. Any other questions? Okay, thanks once again for coming. Our next meetup is going to be on November 6th. It's not actually the Big Data meetup, it's an HPC meetup, but it's going to be in the state of HPC. And one of the commenters and contributors to HPC, Nick Diminic, who also works at Hotternox, he's going to come and do the talk. We also have a meetup on November 12th and November 18th. If you look up the meetup page, you'll probably get more information. So thanks once again for coming, and I hope to see you next time. And if any of you are in New York City next week, ping me, we can probably meet up. Thanks again. Sorry. One last thing, we're going to be raffling off a bunch of things out here. If you have your raffle tickets, hold on to it. We're going to invite, one by one some folks from Philosophy to come and do the raffle. So, Sarita, please go ahead.
I'd like to request our Chief Architect Neeraj and our Director in Product for our core product, David Moynan, to come over so we can raffle up. Anybody who's holding the raffle ticket, could you please come up? We have some few things to share with you all. I just read the numbers. David, can you come up too? Anybody holding a raffle ticket, please come over. We have a lot for everybody. Jimshah, can you please help put the lights on?
You're kidding?
Please come over and take the last pile of positions. And there's a mark.
Yes. I don't know how many releases before 1.0 they'll call that GA. So I think the timing is a few months
We'll contact you.
Did it make sense? Did it make sense?
Yeah.
Oh, thanks for organizing the meeting. Chris.
Just a quick question. How many of you would like to enter a hackathon at Velocify on the sales software or the data set on